The universe in a mirror, the mysterious world of antimatter. Imagine a universe identical to ours, but completely opposite. A realm where every particle we know has its evil twin, identical in almost everything except for one crucial characteristic, its electric charge. Welcome to the fascinating and enigmatic world of antimatter, a concept that seems straight out of science fiction, but is as real as the air we breathe. Antimatter is not an invention of fantasy writers, but a scientific reality predicted by physicist Paul Dirac in 1928. Dirac, while working on unifying quantum mechanics and special relativity, came across equations that suggested the existence of particles with properties identical to those known, but with opposite charge. Thus, the concept of antimatter was born. Every particle of ordinary matter has its antimatter counterpart. The electron, for example, has its antiparticle called the positron, which has the same mass but positive charge. Protons have antiprotons, neutrons have antineutrons, and so on. It's as if the universe had a perfect but inverted reflection of itself. What is truly amazing about antimatter is what happens when it encounters ordinary matter. When a particle and its antiparticle collide, they annihilate each other in a flash of pure energy, converting all their mass into radiation according to Einstein's famous equation, EEmC2. This annihilation process is the most dramatic manifestation of the equivalence between mass and energy. The existence of antimatter is not merely theoretical. Scientists have managed to create and manipulate small amounts of antimatter in laboratories. CERN, the world's largest particle physics laboratory, has created anti-hydrogen atoms and kept them in existence for significant periods. These experiments not only confirm our theories about antimatter, but also open the door to fascinating practical applications. One of the most promising applications of antimatter is in the field of medicine. Positron emission tomography, PET, uses positrons, anti-electrons, to create detailed images of the human body, allowing doctors to detect diseases at early stages. However, antimatter also poses one of the greatest mysteries of the universe. According to our theories, the Big Bang should have produced equal amounts of matter and antimatter. If this were the case, everything would have annihilated each other, leaving an empty universe. But here we are, in a universe dominated by matter. What happened to all the antimatter? This asymmetry between matter and antimatter is one of the deepest enigmas of modern physics. The implications of antimatter extend beyond particle physics. In popular culture, it has inspired countless science fiction stories, from spaceship propulsors to weapons of mass destruction. Although these ideas are usually far from reality, producing even a gram of antimatter would require astronomical amounts of energy. They demonstrate how this concept has captured the collective imagination. As we delve deeper into the study of antimatter, fascinating questions arise. Are there regions of the universe dominated by antimatter? Could we someday harness antimatter as an energy source? What would the discovery of the matter-antimatter asymmetry tell us about the early moments of the universe? Antimatter reminds us that the universe is much stranger and more wonderful than we could imagine. It is a testament to the elegance and symmetry of the laws of physics, and at the same time, a reminder of the mysteries that still remain to be solved. In every particle and antiparticle, we see reflected the complexity and beauty of the cosmos, inviting us to continue exploring the deepest secrets of reality.